In this video, we're going to look at a couple of applications of quadratics, kind of like quadratic word problems. And so we're going to start with a pretty easy example. It says, a square lawn has an area of 625 square feet. A lawn sprinkler is placed at the center of the lawn, and it sprays water in a circular pattern, and it covers as much of the square lawn as possible. What is the radius of the water sprinkler? So I'm going to start by just drawing a picture of this. So we've got that, and I'm going to kind of try to draw a circle that kind of takes up as much of that lawn as possible. We know that the area of the square equals 625, and I'll put my units square feet. But then what we have is we have this circular lawn sprinkler, and I've kind of drawn the circle, and then we know that the radius of that is what we're trying to find. If the area of the whole square that I've drawn is 625, then what's the radius of this circle? And so what we're going to do is we're just going to use what we have to set up an equation. For example, I know if this is the radius, then I know that that same radius would go this way. In other words, that this radius plus this radius would be the diameter, and that diameter obviously would be the same as the side length up here. So I could label this top side as 2r, because it's going to have the length as the radius times 2. And then since it's a square lawn, that's going to be 2r, and I could say that this side over here would also be 2r. They're going to be the same. And so now we have enough information to set up an equation. I can now say that length times width equals area. And this is just an equation that we can solve. And this is basically the equation that we're going to solve to find our radius. Whenever I multiply 2r times 2r, that's going to become 4r squared equals 625. And then what I'm going to do is I'm going to divide by 4 on each side of this equation, because we're going to try to isolate that r squared. And so our r squared is equal to 156.25. And then lastly, I'm just going to solve with roots here. If I take the square root of each side, we're going to be left with the fact that the radius here is 12.5. So, well, that one didn't seem too complicated. Keep in mind, this right here is a quadratic equation. This is a quadratic term right here, and we're solving for r. So this would be one type of example you might see for a quadratic word problem. So this next one says the product of two consecutive odd integers is 195. What are the numbers? Now, this one's a little bit tougher. And so what we got to think about is what we're trying to find is we're trying to find a number, and I'm going to choose to represent that number with n. You can use whatever variable you want. But it says two consecutive odd integers. So what you have to think about is what's the relationship between a number and the next odd number? For example, if this number was 5, the next odd number would be 7. If this number was 13, the next odd number would be 15, so on and so forth. So I could represent one number with n. Okay, that's like our first number. But then our second number would be represented as n plus 2. It's going to be 2 greater than the first one. And that's going to be our second number. And so from there, we can write an equation. It says the product of two consecutive odd integers is 195. Product means multiply. So that would mean that our first number times our second number equals 195. And now we've set up our quadratic equation that we can solve. I'm going to go ahead and distribute, and we have n squared plus 2n equals 195. And then I'm going to rearrange this so that it's equal to 0. And from here you've got your quadratic set up, and you can really just solve this using whatever method you want. I think I'll probably solve with the quadratic formula. Factoring might not be too bad if you could find the factors of 195, but I'm just going to go with quadratic formula. So we have that our a is 1, our b is 2, and our c is negative 195. So I'm going to use my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now let's just simplify that a little bit further. We're just going to take it step by step. Negative b plus or minus the square root, and then 2 squared is 4. And then whenever I multiply 4 times 1 times negative 195, or excuse me, negative 4 times 1 times negative 195. That's going to leave me with 780. And now when I take the square root of 784 on my calculator, I get 28. So I'm going to kind of move up here where I have a little bit more space to finish out this problem. We are now at the point where I wrote x equals. I guess I should say n equals since we're using the variable n. So n equals negative 2 plus or minus 28 over 2. I can divide a 2 into both the numbers in my numerator, so I have negative 1 plus or minus 14. Now I'm going to break that into two separate problems, one where I add and one where I subtract. So I have negative 1 plus 14 and negative 1 minus 14. And so, as often we do with quadratics, you're getting two different answers. But you might be sitting here and you're saying, okay, well, I get it, but for one, these answers don't multiply to give me 195. They multiply to give me a negative 195, and they're also not consecutive odd numbers. What we got to think about is we solve for n. N represents the first number. So what we have is we have not two different numbers here, but we have two different combinations of numbers that satisfy this. For example, let me come down here with my negative 15. If my first number is 13, that would mean that we can just add 2 to it to get our second number, which would be 15. And then down here, if I took the negative 15, which is also a good solution, and I added 2 to it, we'd get negative 13. So this would be one set of numbers that satisfies this situation, and this would be a second set of numbers that satisfy this situation. Obviously, a positive times a positive is a positive, but also a negative times a negative is a positive. You've got to be really careful with how you interpret your answers down here at the end of this problem.